Okay, I'm going to be going over the quiz, a couple problems on the quiz, the back page. So this is the very first one, and a lot of you did well on this. This was worth 2 points. And so I'll just lead you through the answer key, but I've also built a model, so maybe that'll help. Your first job is to figure out the stereochemistry here. So you just go through, figure that out. It happens to be S. And then as you're looking at it, you can't look and sight down this bond and be looking from left to right, which is the way I always set up my Newmans, so I know the dashed wedges are over here and the solid wedges are over here. So because I use this mnemonic of knowing the three-dimensionality of this particular setup, it means I have to look from left to right. So all that means is I always just set up my carbonyl on the left. There's my eyeball. I'm going to sight down this bond right here. Okay? And all I have to do now is set up this chiral carbon so it's still S. You can do that however you want. But you also want to keep in mind, so a nice easy way is shown here. That happens to be S still. You have to keep in mind that this big stuff here, that's the largest substituent on this neighboring chiral C that you're going to have on the back. That's going to be eclipsing with this hydrogen. So I'm showing it just on a plane line going down here because I'm going to eclipse it when I rotate around that bond. Alright, and what I mean by that is, so here's the molecule. Here's your C double bond O. There's that aldehyde H. These two blue things here are your large group, right? Your methyl. Here's your chiral carbon. And I've made sure I've built it up, correctly, so it is the S configuration. You are going to be sighting down the C double bond O to chiral carbon bond. And you have to have this H here. I'm hoping this shows okay. The aldehyde H has to be eclipsing with this large group, and that means you're spinning it like so. Okay, so now you're sighting down the front carbon with the C double bond O to the back carbon right here. Right, there's your back carbon. And here's your two large groups. Take a look at what happens. This hydrogen here is off on the left-hand side of the Newman that you're going to draw. And I'm just pointing that out because the hydrogen there is the small group, right? So we talked about how the nucleophile, this is CRAM's rule, the approaching nucleophile, whatever the heck that thing is, methyl, ethyl, whatever, is going to come in on this face where there's less steric hindrance. Because look at all the steric hindrance right here. So the nucleophile is going to approach the carbonyl from this small side, okay? Because you're sighting down this bond. I'm going to set this aside and go back to the problem. So here's my nucleophile. There's the small group right here. Here's those methyls that were in blue. See how they're eclipsing with the aldehyde H? That's how CRAM set these up. And this is just the rest of the ring, however you want to draw that. Okay, when the nucleophile attacks, your OH is here. There's the nucleophile, the methyl. Right, there's the large groups off on this side. There's the H. So those two things end up close to each other. The last part of the problem now, you're like in the final stretches, to turn this Newman into a 3D structure so you can tell me what is the stereochemistry at this new chiral carbon, right? It's dictated by the stereochemistry on that back carbon because it has a large group, a small group, and a medium group, right? The CH2 playing the role of the medium group. So, when you reconstitute a Newman to a 3D molecule, if you've looked from left to right, which we carefully set up, on this side is your dashies, right? Your dashy wedgies. Over here's your solid wedgies. So here's my front carbon with an OH pointing up on a plane line. The back carbon's going to have this big group on a plane line pointing down. That's a critical setup piece too, right? You have to set up this up-down relationship. Remember the Newman cheat sheet on the plane lines. Now you're ready to decorate it with the dashed wedges, methyl and H, and the solid wedges, CH2 on the ring, and the H coming out at you here. You end up with S for both carbons, right? You started with an original one that was S, and that new one you created has to be the S enantiomer. So your final answer is U. Okay, and again, H is coming out at you here, so you invert your answer to S. I hope that helps on that one.